Okay, for today we're going to look at section 11-4, inscribed angles. An inscribed angle is an angle whose vertex is right on the circle, but whose sides each contain chords of the circle. So when you have two chords of the circle, if they meet to form an angle where the angle is right on the circle, then you have an inscribed angle right there. An intercepted arc has to be the arc that is formed inside the edges of that circle, but it still has to be, or inside the edges of the angle, but it still has to be part of the circle right there. But it's from one end of the angle to the other end, and these two have a relationship. This is the intercepted arc, this is the inscribed angle, and the next rule is going to tell us what the relationship is. If you have an arc that goes across the circle or around the circle like this, the rule says that if you have an angle that is inscribed in a circle, we'll inscribe it from this arc right here, then the angle here will always equal half of the arc. Whenever the angle is inscribed on the circle, whenever the angle is right on the edge of the circle, then you have half. All right, half of the arc. Whatever this arc is, this angle is going to be the arc divided by 2. And it works both ways. If you know what the arc is, then you multiply by 2 and you'll, or know what the angle is, and you multiply by 2 and you'll get the arc. All right, just watch these. You don't have these examples on your paper, but I just want you to see it. When the angle is right on the center, then the angle and the arc match exactly. The angle equals the arc. But when the angle is on the circle, not on the center of the circle, then the angle equals half of the arc divided by 2. So if the angle is 86, then the arc, or if the arc is 86, then the angle is 43. The angle is half of the arc. The arc is bigger, the angle is always smaller. Here, same thing. When the angle is on the center, the angle and the arc equal each other. When the angle is not on the center, when it's on the circle itself, then the angle is smaller than the arc. The angle is half as big as the arc is. Some people get confused. When do I make it bigger? When do I make it smaller? Think of it this way. If you start off with the angle and you want to know what the arc is, it's getting bigger and bigger and bigger, so you multiply by 2. Okay, but if you're going the other direction, if you know what the arc is and you're trying to figure out the angle, it's getting smaller and smaller and smaller, so you'll divide by 2. Let me show you a few examples like that. Since this angle is right on the center, your rule is that the angle equals the central, or equals the arc, so this is 70 degrees as well. But this one's on the circle. When the angle is on the circle, the rule is that the angle is half of the arc. So take your arc, 70 degrees, divide by 2, take half, and you get 35 degrees. And don't forget, if I'm going too fast, you can stop, you can pause, you can go back, and you can watch it again. This one's different though. The angle's still in the center, but I don't know what the arc is. I know what the angle is. The angle's on the center, so the two are equal to each other. But this one, where the angle is on the edge of the circle, the angle is half of this arc. So as it's getting bigger and bigger and bigger and bigger, you multiply by 2 and you get 100 degrees. If you go the other way, 100 divided by 2 is 50. 50 times 2 is 100. So we'll practice that more in class. I just want you to see the rule and make sure that you've got it down. All right, and that's the same idea. We don't need to go over it again. All right, there are really 2 or 3 main rules that you need to see. We don't use them all the time, but you need to make sure you get them now and you get them written in your Know It notebook so that you can use them when it comes time for the tests or for the quizzes. If 2 inscribed angles of a circle or 2 congruent circles intercept either congruent arcs or the exact same arc, then the angles themselves are congruent. Here's what it's saying. Here's an angle. It's inscribed in the circle. And here's another one. But as it's inscribed in the circle, it's also has the same points as the red one does. It's intercepting the same arc down here. And when that happens, when they intercept the exact same arc here, then you can see that they both equal half of that arc. What that means is that they end up being equal. When they both intercept the same arc, then they are equal to each other. This angle is congruent to this angle. Let me demonstrate that for you. If you have an arc that's 140, whether it's blue or whether it's purple, it doesn't matter. It's 140 degrees. Let's start with the blue angle. The blue angle is half of that arc. The angle is always half of the arc. So what's that angle right there? Yes, you're correct. It's 70 degrees. And look at the purple one. It's the exact same arc. It's 140. But if you're going to do the angle, you take half of it and you get 70 degrees again. That's why these two angles will always be the same, because they're half of the exact same thing. They're both half of the same arc. So anytime you have two angles that intercept the exact same arc, make those two angles equal to each other. All right, one other rule is if an inscribed angle of a circle intercepts a semicircle. Semicircle is half a circle. It goes halfway around the circle. That means it's 180 degrees. It connects with the diameter. If you've got that, and you've got 180 degrees right here, think about it. If you have an inscribed angle that intercepts this particular arc, it's going to look like this. Do it in a different color. This angle that's being created, and from this endpoint also, it's being created there. The angle is half of the arc. So if this arc is 180 degrees right there, then this angle that intercepts it also has to be 90 degrees. Has to be half of 180. 180 divided by 2 is 90 degrees, which is a right angle. Or backwards, if you have a 90-degree angle here, then you know it's going to be a semicircle right there. And the last rule that you need to make sure that you get is if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. And that's not a parallelogram. Okay, it's different than the parallelogram rules. This is not a parallelogram because the opposite sides are going weird directions to make sure that it all fits into the circle. So if a quadrilateral is inscribed in a circle, meaning that all the vertices are actually touching the circle, they're all encompassed inside the circle except for the corners, then opposite angles are supplementary. Oops, I almost said the parallelogram one there. Opposite angles are supplementary. So what you need to do is always look for 180. That's what supplementary means. Two pairs of angles that add up to 180, but it's the angles across from each other this time. These two pairs of angles are supplementary to each other. They are going to add up to 180. And likewise, these two angles opposite from each other are going to add up to 180. Opposite angles are supplementary. So for example, you don't have this on your paper, but we'll do examples tomorrow. But looking at this one, think about opposite angles are supplementary. This angle is supplementary to the one across from it, 50 degrees. So to figure out what x is, all you have to do is 180 minus 50, and you get 130 degrees. 130 right there. Opposite angles are supplementary. Likewise, these two right here, since they're across from each other and the quadrilateral is inscribed in the circle, I can say that these two are supplementary. So to figure out what y is, all I have to do is make them add up to 180. So 180 minus 140 will equal 40 degrees. And that's my answer for this one right here. 40 and 140 are 180. 50 and 130 are 180. And we'll be using those rules to practice tomorrow. Okay, that's it for today. Thank you very much.